So in this tutorial we're going to have a look at how you would use SOLIDWORKS Plastics, which is an add-in for the main SOLIDWORKS program, and you use SOLIDWORKS Plastics primarily to simulate the injection molding process. So I have a sample part here, just a simple injection molded part. And I'm going to run through some of the setup steps that you must address before you can simulate the molten plastic being injected into the mold cavity. So the first thing to say is SOLIDWORKS Plastics is an add-in, so it may not be active currently on your system. So the way that we check that is we go to the SOLIDWORKS Add-ins tab, or maybe go down to the menu using the Tools and Add-ins menu, and then we activate SOLIDWORKS Plastics. So click on the SOLIDWORKS Plastics icon. The screen may jump slightly like mine did. That is just the add-in being loaded into the current session of SOLIDWORKS. Now if, like me, you have other add-ins active currently, you may run out of space for new tabs at the top of your work area. So you can see I currently have the SolidCam add-in active, so there's lots of tabs here, and I've run out of space to show the SOLIDWORKS Plastics tab. But if you hover over this last tab here, that is the beginning of the SOLIDWORKS Plastics tab. So rather than close SolidCam down, I can just click on that. But if you're having real trouble, you could go to your add-ins menu and switch SolidCam or any other add-ins off and just leave SolidWorks Plastics active. So this is the command manager for SolidWorks Plastics, and what we're going to cover in this tutorial is some basic setup steps to create a very simple, very basic injection molding simulation. There's far more content that you can learn about within SolidWorks Plastics if you want to create more realistic simulations, but those simulations tend to come with a calculation time increase, because the more detailed or the more realistic your simulations become, they tend to take longer to calculate. So you will have to wait longer for your results to be calculated. So the first thing that I'm going to address is what is the simulation type that I want to run within SolidWorks Plastics. So if I click on simulation type, my intention is to not actually change anything in this menu. I'm just showing you where you would access these options if you needed to change them in the future. So the two options that are on by default is a filling simulation, which is essentially simulating the molten plastic being injected into the mold cavity and filling the cavity. Now what can happen in certain corners of the cavity or hard to fill areas, that fill can not quite reach the cavity walls, and so there's what's known as a packing phase as well, where the pressure of the molten material is increased by the injection machine in an attempt to ensure relatively even and full distribution of the plastic within the mold. So we're going to leave both of those options switched on. I would call this a bare minimum. We could actually switch packing off, but that is really quite a simple simulation then. So we'll leave packing switched on for our purposes. And then as soon as I accept that, I'm navigated into the Plastics simulation tab. So it's represented by this P here. So I've set my simulation type. I'm going to move on down here and set my material that I'm going to use for my injection process. And the way that we do that is just right click where it says material and then apply or edit a polymer. And there's a vast library of polymers available inside SolidWorks Plastics. So I'm just having a look at all these polymer suppliers or manufacturers that we can simulate their polymers. So let's have a look inside one of these. You can see for a given supplier we have multiple polymers that they can supply us with. So it's quite a fully featured database of materials. So let's just pick one of these. So let's pick an ABS material from this particular manufacturer. And the way that we do that is just put a tick box at the side of the material that we want to use, and then accept. So I clicked on the OK button at the bottom, and you can see the polymer that I've chosen is listed there. So that's that addressed. The next thing that I really need to do is I need to tell the system where I'd like to inject the material. So there must be at least one entry point for the material to enter the mold or the molded shape. So where would I like to put that? So let's assume that we don't know much about the injection molding process. We're relatively new to the injection molding mold design field. So it might be nice to have the system advise us where would be a good point to put our injection location. So we right click on boundary conditions, and there's an injection location advisor that we can use for that. And as long as you've designed your part with required draft, the system is normally pretty successful at identifying which directions the mold tools would split away from each other. So we can see in my case the mold tool directions are correct. If that wasn't correct, I could switch from automatic to user defined, and I could pick a flat surface to define that. So I'm just illustrating how that works. Or probably more wisely, I could pick one of the primary planes of my part to define that. As it happens, that's not required in this case, but I'll leave that top plane selected just to illustrate the point. Now I'm not going to run a simulation with multiple injection points in this case, but just know that that is an option. You can get advice on the location of up to 4 injection locations, but we're going to leave that set at a single injection location. And then the last thing that we can edit before we get this advice is we can exclude certain regions of the part. So given that this product will have its external faces seen regularly by the customer, it might be nice to mark all of those external faces in this box as excluded regions, so that the suggested location or advised location of the injection point does not end up on the outside of the part, because it can create a visual error on the outside of the part, a small piece of material just sticking out from the face, which we don't want in this case. So we've excluded all the external. Let's preview the result, and we get our common kind of rainbow plot that we see a lot in simulations of various types. And the scale here basically ranges from the most recommended location down at the bottom here to the least recommended location. And then the actual location that the system is recommending we place our injection point is shown using this arrowhead here. So that's all seems fine. I don't have any issues with the position that it's chosen there, so I'm just going to accept. And then that injection point will be created by the system. There it is. So we have an injection location now. So there's not many steps left to do. The major step that we have left is we must subdivide the solid body, which is our part, down into a finite number of meshed points or nodes. And the way that we do that is click on solid mesh, create mesh, and in our case we're going to create a mesh with the default setting just to see how small the elements are within that mesh. So if you click on create, it will take it a few seconds just to create this mesh. So this is what it's done. It's meshed the part, or it's converted a continuous solid body into discrete elements with discrete points in space where those elements meet each other. So at the points of these triangular faces, there is a node. So there's one node where the points meet each other, there's another node. And depending on how many nodes we have in our mesh, the calculation can take longer or less time. So the more nodes, the slower the calculation, because the system is doing quite complex calculations at every single node point. So if we have 10 times as many node points, our calculation will take 10 times the length. So we're not going to go with the default settings. We're going to turn our mesh fineness down to its coarsest setting, and then we're going to recreate our mesh, because we want these results to run as quickly as possible. In this instance, we're just going for a very quick look at our results. We're not too bothered in the detail or the realism at this point. So I'm happy with that mesh. I don't have a problem there. So I'm going to click on the green tick. Again, this is probably what I'd describe as a quick run through of the necessary setup steps. There are many more options that I would recommend that you become familiar with if you want to add more realism to your simulation results. So at this point, I can run the calculation. So there's a run button at the top of the screen. Because I have fill and pack active, that doesn't mean that I always have to calculate fill and pack. It just means I have options. When I click on run, if I only need a fill analysis, I can choose to run that. Or if I want a fill and pack analysis, two separate things there, a fill analysis and then a pack analysis, I can choose to run that. So when we did that setup initially, that just defines what options are available in this run menu. So let's run with a fill and pack analysis. So this can take quite a while depending on the specification of the machine that you're running these calculations on. But what happens almost immediately is we get an analysis manager window, and it has various pieces of information such as what is the name of the setup that we're simulating. This is just the default setup. What type of analysis are we running? Fill and pack analysis. Is the calculation currently running, or has it completed? So this one is still running, still calculating. And then we get much more detailed kind of information down below. Some of the things that to the novice user we can interpret. What volume of the part has been filled? You can see there mine's filled by 5%, 15%, and then lots more information to do with temperatures and pressures and things like that. What I'm going to do, I'm just going to untick this little box here, because that will mean the analysis manager window will kind of hang around at the end of this calculation phase. The default is to have that ticked, and the analysis manager will disappear instantly once the calculation is complete. And there may be some values in here that might be of use to us. So I'm unticking that value. So what I'll do is I'll pause now and let this run, and we'll come back when all the calculations are complete. One thing to say before that, you can see that as these calculations get nearer and nearer completion, the graphic in the background is reflecting that. So it's calculated everywhere from the injection location to this flow front currently. So halfway through this process, the filling portion of the calculation will complete. But this isn't the entire completion of the whole run. So you'll see filling stage complete, and you are actually free to have a look at some of the results at this point. but it's probably safer if we just let this continue to run until the packing portion of the calculation is complete as well. So I'll pause and we'll come back when that's complete as well. So here we are with the calculations complete. So both calculations have completed, the filling calculations and the packing calculations, and this is the readout that you'll see as the last piece of text in the Analysis Manager window. One side note to that, if you began investigating the results before the Analysis Manager had completed, maybe you had to minimize the Analysis Manager window like that, and it's not immediately obvious where that window has gone, but it will have gone down here into your quick access menu, and if you just double click on it, it will come back. So this Analysis Manager window has lots of information in it that may or may not be useful. If you're running multiple simulations and you're interested in comparing the calculation time between simulations, maybe you're playing with the size of the mesh elements, or maybe you're running a more thorough simulation with warp analysis and some of the other options enabled, it is often nice to compare how much extra time those analyses take. So you can just take notes on the total CPU time here, and then you can do a comparative analysis. And there's lots of other useful information in here. So it can be nice just to kind of browse this window when calculation is complete. But we're going to shut that window down now, so I'm just closing it. And we're going to have a little look at the results that we've got here. So we have various results listed down at the left hand side here. These are all the fill results. So if we just click through some of these, and again for the novice at injection molding, there's a helpful results advisor that pops up at the right hand side of the screen, and whichever type of plot I click on here, the results advisor takes me to the relevant information that describes what I am actually seeing in the plot, and it also tries to give me some advice on how I might improve any analysis plots which are poor. And then at the top of the screen, it tries to give me some specific advice on the results that I am seeing specific to my part. So this section is just from the help file, but it is quite useful on the topic to do with shear rate, in this case at the end of the fill. And this information is compiled and specific to the results that I am seeing for my particular part design. So it's worth taking some time and just kind of working your way through all these results and seeing if you have any potential issues or major issues within your part. So let's assume that we've seen an issue here, and some of the advice that we've been given is to maybe experiment with the wall thickness in our part. So that's quite a common design change that you can test if it has a positive or negative effect on your results. So let's assume we've got to that point. We've seen a result that we don't really like too much, and we've decided that we're going to change our part design to try and get some more favourable simulation results out of SOLIDWORKS Plastics. So the first thing that I would do in that process, I would accept these results that I'm seeing. One thing to say just before we begin to edit the part wall thickness is if I need to get back to those results at any time, they're just in this results folder. So we were looking at the fill results. Let's say we wanted to go and look at the pack results. I could just double click on pack, and we get a very similar screen, just informing us of the results of the packing analysis. And in this case, the results advisor hasn't automatically opened over here, but that's easy enough to correct. If you click on the question mark, the results advisor will open or close depending on whether it's open at the moment. So that's how we get back into our results and view them again. So I've already said, let's assume that we saw a troubling result of some description there, and we read the advice there, and one of the things that it advised that we try is maybe maybe editing the wall thickness, the current wall thickness that our part has been designed with. So this part in particular was designed with a 1.8 millimeter outside wall. So I'm proposing, or I'm going to vary that thickness to 2.2 millimeters thick. So here's how I would do that. So the first thing that I want to do is I want to create a second study, because I want to retain this study so that I can refer back to it in the future. So the way that we do that, rather than just editing this study and losing it, because it will be overwritten by our new study, we can duplicate it and retain the original. So the way that we do that is that button there, duplicate study. And I would recommend that you give all your subsequent studies a descriptive name of some type. So I'm going to call my study 2.2 millimeter wall. That's enough of a clue as to what I have changed in the new study. So I've changed the wall from whatever it was previously to a 2.2 millimeter outside wall. And I don't need those results files that I've already generated, because I'm going to generate some new ones. So I'll tick there, copy without results. Okay. So it will take a few seconds just to copy the study, and then it will take me into the new study. So if we look at the top of our Plastics Manager, SOLIDWORKS Plastics Manager here, the name of the study that I'm currently in is listed. So I'm in Plastic Study 2.2 millimeters wall. If at any point I want to go back into any of my previous studies, this is how I would do that. So I would go into the Configuration Manager tab, and then I would see any studies that I'd created in here using the duplication process. So there's the one that I just created, the one that I'm in currently. This default one is my original study. So if I want to go back in there, I just double click. And the new study will become grey, and the previous study will be in black text. So whichever one is in the black text rather than the grey, that is the one that you are currently in. And if I go back into my Plastic Manager tab, you can see I'm in my original study here. And if I wanted to look at my original results, I could, just by double clicking on them. So that's a little bit about how you navigate between studies. So let's go back to our new study. So in there, double click on my new study to activate it. And I want to make that change now. I want to modify the part to have a 2.2 millimeter wall rather than its original 1.8 millimeter wall. So the easiest way to do that in this part, because I know that these inside surfaces were created using a shell command, because of the way that I designed this part, I can just click on one of these faces and the thickness of that shell command becomes visible. So there it is. And not only is it visible, if I quickly double click on it, this menu can be a little bit tricky to get into. If you don't see this menu, the modify menu, press escape and try double clicking again until you do see this modify menu. So my intention is to change this to 2.2 millimeters, but before I do that, and this step is absolutely essential, before you change that value, you must go to this drop down arrow here and tell the system I am only editing this configuration. So in our case, I am only editing the configuration named Plastic Study 2.2 wall. I do not want to edit the original, the default. If you do not do this step that I'm showing you now, to tell the system you only want to edit this configuration, the original results and the original design will be lost. So tell the system you are only editing this configuration, not all configurations. So this configuration only, and then you're free to change that value to whatever you need to. So in our case, that would be 2.2. And then the model will not update automatically. You will have to do a regenerate. So there's a regenerate button in here that if I press, the wall will move in slightly. Or if I choose to accept this, there's a regenerate icon at the top of the screen at all times there. It's the same icon. But let's use this one in here. So keep an eye on the wall and it should shift inwards slightly. Regenerate there. All the walls on the inside of the part shifted in slightly. So the part is now updated. So I'm going to accept that by clicking on the green tick. And then a little pop-up has appeared at the bottom right of the screen. It's just informing me there's something out of date or something has been modified and my plastics study is now out of date. So I must remesh and in actual fact I must recreate the injection location as well. So let's go back and do that in our Plastics Manager. So here we are back in our Plastics Manager tab. The injection location has got an error because the injection location is now buried inside the part because that bottom wall has moved upwards slightly. And the mesh is no longer correct because the mesh is the shape of the previous 1.8mm wall. So the mesh needs to be recreated. But neither of these are huge problems. The way that I'm going to deal with the injection location problem is click on it and right click and say delete. And then I'm just going to recreate a new injection location just as I did before. So boundary condition, injection location advisor. I'm not having anything more than one location. I'm not going to modify the mold opening direction this time because it's got it correct again, although I could do if required. And then excluded regions, I just want to mark out all the external faces again, just so that it doesn't put the injection point on there, like that. And hopefully it'll come up with a similar result, almost dead center in the middle of that face there. Result preview, yes, that looks fine. Because I gave it largely the same input. It's just that this lower face in here is now 0.4 of a mil higher. That's all. That's the only thing that's changed. So the injection location should be almost identical. And then the solid mesh, I just right click, create mesh. I don't need to change anything in here. And then I just click and it will recreate a similar fineness of mesh quality. So we'll give that a second just to update everything. Yep, we're okay there. And then we can run again. So if we click on run, fill and pack, and then again I'll pause here and we'll come back in when those results have completed. So here we are, the new calculations have finished. We can see that. So I'm going to close the Analysis Manager window, and this is where we have the ability to look at the plots from this simulation with the 2.2 wall and compare them to the plots that we were seeing in the default setup, the default configuration with the 1.8 wall. Now there's no kind of easy built-in way, certainly in SOLIDWORKS 2023, to do this. I believe in the 2024 version there's quite a nice tool where you can get similar plots on the screen simultaneously so that you can compare them visually. But the way that I'm going to do this is I'm going to pick a plot that I might be interested in. So let's have a look at volumetric shrinkage here. I'm going to frame the plot relatively centrally on the screen. And then I'm just going to take the Windows Snip and Sketch tool. So I've got Snip and Sketch open here. And I'm going to take a snip and sketch of the relevant piece of the screen there. So the scale, the plot itself, and just the title of which plot I'm viewing there at the top of the screen. And then you can kind of minimize that, or you can shift it off temporarily to a different screen. Close these results down. Go back into your original default configuration. So double click. And then I'm going to call up the same plot, my volumetric shrinkage plot, from that configuration. So back into Plastics Manager, into my previous fill results, and it was volumetric shrinkage at the end of fill, and there is my original result. So this can be a little bit tricky. You kind of have to, if you have two monitors or more monitors, this is relatively easy. You can take your snip and sketch and put it on your second screen. If you have a single monitor, you're going to have to kind of shrink things down so that you can see the two plots side by side. So is there any discernible difference? There's a very small difference in the scale at the top extent. So the maximum shrinkage here is 7.9 something %, and it's largely the same over here. These last two significant figures have changed, but no real huge amount of difference. Down at the bottom of the scale, we've seen a larger change. It might be nice to kind of look at the distribution that we're getting. Again, nothing too drastic has happened here because of our wall thickness. But we could use this technique now to analyze some of the other plots. So let's look at, say, sink marks from our original configuration here. So sink marks is what I'm looking at. Again, we can use any kind of snipping tool that allows us to take a screen grab of what we're seeing on the screen there. So we'll get all the relevant information in a screen grab. And then we'll exit these results and go and activate our second study with the 2.2 millimeters wall thickness. And then activate our fill results again. And this time we're interested in sink marks. So I'm not going to bring the other plot on the screen this time. I'm just going to kind of glance across to my other screen that I have the plot visible on. So the max has changed slightly, and if I rotate over and just kind of see where the worst sink marks are, yeah, I've slightly varied the max value here. So again, this can be quite time consuming, and we didn't really identify any particular plot that we were unhappy with. We're just kind of looking at the workflow and the process that you would have to go through to be able to compare these two. So let's assume we've made a decision now that we would like to test numerous different configurations. The easiest or the most time efficient way of doing that is to set up multiple configurations of your part. So say we wanted to investigate wall thicknesses at 2.4 and 2.6 and 3 and maybe 3.2 and maybe 1.6 as well. So multiple different variants or configurations of our original part. We could set all those configurations up just using the duplicate and then edit techniques that we've used already. And then we could use something called Batch Manager to calculate the results of all of them simultaneously. So we wouldn't have to keep manually managing the calculations. So let's see how we would do that. So let's add one more configuration just as an example. So then we'll have 3 different configurations. So again, duplicate study. What am I going to change on this study? Well, let's make a 3mm wall variant of our part. We don't need the results. So it will copy everything over to a new configuration, which should appear there. There it is. This configuration is the one that is active currently. How do I know that? Because the text is in black and the other two configurations are in grey. So this is the active one. How do I enact that change? I click on the feature that I want to edit. All its governing dimensions will become visible. I double click on those dimensions, tell the system I only want to affect this configuration, and then I'm free to change that value to whatever I need. And then in order to have that update affect the shape of the part, I have to regenerate the model. So regenerate. That wall will step in our case, and then I can accept that edit. So again, our mesh and our injection location will be out of date again. So I can go and fix those problems. Let's delete that and recreate. We should be relatively quick at this now. Excluded regions. This may work if I just simply exclude that face there. Let's see. I suspect that will work. Yeah, that was enough. So we didn't have to select all the outside faces. Because if it couldn't put it on the outside there, it just went to the exact same location but on the inside face. And then we can just create our new mesh. So that may take a second or two. There we go, that's all done. So we now have 3 configurations. So let's imagine we hadn't calculated anything for this original one, and we hadn't calculated any results for this second one, and we certainly hadn't calculated any results for this third one. Let's assume we just went through setting these simulations up, or duplicating the original one and making a slight change. So let's assume we'd never pressed the run command for any of these. So we've queued up 3 simulations that we'd now like to run. And you can queue up as many of these as you require. So if you wanted to investigate other things other than wall thicknesses, maybe you want to remove the ribs entirely and run a simulation to see what effect that would have, you can do that as well. So you can have as many configurations as you need. Then when you've set them all up, so you've been in here and made a mesh and set the injection point and maybe change the materials, which you can do per configuration. If you click on Batch Manager, then you're confronted with a new menu here, and any configurations that you've set up will be listed in this portion of the window here. So you can see we have 3 configurations. We have the default, we have Plastic Study 2.2 wall, and we have Plastic Study 3mm wall. That should be named. And what we can do is select one of our configurations. So I'll select the default, select what type of analysis we'd like to do. So I want fill and pack, and then double click on the plus sign, and it will be added to the batch list. So there is my default, my original. There is the type of analysis that I want to run, and it's saying pending being run. So I'll add the other 2. So here's the second one with the 2.2mm wall. I need a fill and pack analysis. Double click to add it. There it is. And then the third one that I've created, fill and pack, double click to add it, and there it is. So you can build these up. You can put as many as you require in this list. And then when you're ready to calculate these results, so again, we're imagining that we never calculated any results for the default or any results for the 2.2mm wall. We just did the setup on all 3. At this point, when we've populated our list of our batch manager with whatever setups we need to simulate, we click on that start arrow there, and it will automatically run through those fill and pack simulations for all 3 in our case, or more if you require more simulations. And you're free to now leave the computer or do some other work on the computer and just return when all of those analyses have been run. So that's a more time efficient way of working. Queue up multiple analyses, use the batch manager, and allow the system to just run maybe for a few minutes or even hours, depending on how many you queue up, and then just return and view the results and make any further decisions about how you might edit the part or edit the process. So you can see my machine's doing that. I'll probably pause things now and we'll come back in and just kind of round off the tutorial. So as those multiple analyses are running, this is the likely readout that you will see. You can see mine is kind of jogging around quite a bit, but the current analysis that's been solved or calculated will say running, and the ones subsequent to that will say pending. So when they've all completed, they will not say running or pending. They should say complete in these boxes. So here's our completed run of our 3 batched analyses. So if we accept that in the batch manager, and then we're free to activate whichever one of our configurations we're interested in, and then view the results. So let's have a look at the new one, the 3 mil. So we've activated that config. We go into the results and the plastics manager tab, and then let's say we're interested in the pack results. We could activate those results and just begin viewing those results. Now we've seen a method by which we can use the Windows snip tool to compare 2 results against each other. Another option is to generate a report featuring all the results for each one of our setups or our configurations. So from this screen we'd select whichever configuration we were interested in, and then we go down to the results icon, right click and click on report to generate a full report featuring all the results that we've previously been browsing through. And we can give these reports, so these report documents will end up as either a HTML file or a Word file or possibly a PowerPoint. We can choose whichever one is most suitable for us, or we can have a copy in all of those formats. So let's say that we're going to choose a PowerPoint file. We can define where we'd like to save this file as well. So if we want to put all these files in a central location, we can. And then when we click OK, that report should be generated. So the system will take a few seconds to kind of collate all the results that we've been browsing through and include them in that report document. And then we just simply have to wait until that document is generated. We'll see a little progress bar at the bottom of the screen in green, and when that is complete, we can assume that the report has been created. And then if we want to view that report, we can navigate to the folder that we specified we wanted the report saved in, or we can just right click on this icon, report, and then define which format we'd like to view it in. So MS PowerPoint, and here is our report for the configuration that we were working on there. So it allows us to see which configuration name that was, and then there's various pages in this report just summarizing all the results that we were seeing and more. So that's how you would generate a fully featured report for each of your configurations. And if you export these reports, you can then load them up simultaneously and compare the results from each of them. So that's a really quick, kind of simple setup to simply simulate the plastic injection molding process.